Thermal expansion. Thermal expansion is the tendency of matter to expand on heating. This tendency is observed in solid, liquid, and gas. Just take an example. Did you notice that the level of mercury in the thermometer rose when it was placed in the hot water? Well, it happened because of thermal expansion. A thermometer usually consists of a narrow tube and a small bulb at its one end. The bulb and the narrow tube is filled with mercury, which is liquid at room temperature. Now, when a thermometer is placed to hot water, mercury inside the thermometer expands due to thermal expansion, and as a result, its level rises. Another example of thermal expansion is, have you ever wondered why a gasoline also expands on heating? Well, when the tank is filled till the brim and there were no space left in it, so now when the bike was kept on the sun, the tank became hot, which eventually heated the gasoline filled in it. So, as a result, the gasoline expanded, but since there were no space left in the tank, the expansion forced the gasoline to come out to the tank. So that is why the gasoline expands when heating. Now, at this moment, we will now move on to the types of thermal expansion. Eventually, there are several types of thermal expansion, but my topic is with the linear expansion, area expansion, and the volume expansion. So now, we will now move on to the linear expansion. So, when we talk about linear expansion, it is if the change is only in one dimension. So, example is when the expansion is in the linear or in the x component or maybe in the y component. So, one thing is for sure, linear expansion is one-dimensional expansion only. So, mathematically, linear expansion is delta L is equal to alpha dot L naught dot delta T, where our delta L is the change in dimension, while our alpha here, alpha is the constant of proportionality, or in linear expansion, it is the coefficient of expansion, while our L naught is its original length. Then our delta T is obviously this is the change in temperature. Now, we will move on to the second type of thermal expansion, which is the area expansion. So, when we talked about area expansion, it is if the change is in two dimension. So, not only in the x component or in the y component, but it expands both in x and y component. So that is area expansion. Well, area expansion is mathematically can be denoted as delta A is equal to 2 alpha dot A naught dot delta T. So, if you ever wondered why 2 alpha, it is because it is 2 times of the alpha in the linear expansion because it is now both in x and y. So, its coefficient of expansion is in 2 alpha. So, our delta A is also the change in dimension. Our 2 alpha, it is the coefficient of expansion. Our A naught is its original area, and also delta T is the change in temperature.